When we used the lever rule before, we started with a composition, and then we could calculate or estimate the amount on different phases at different temperatures. Now, when we have learned more about the solidification and how different phases are formed during solidification, we will use the lever rule in another way. We can start looking at the structure, and based on how we can interpret that structure and what system we are working with, we can actually calculate the composition, or anyway estimate the composition of that alloy. We will try to do that now in the copper-silver system. Here we have a problem. We have a structure of a silver-copper alloy, which we see here, and we know that this is from the silver-copper system, so we have the silver-copper phase diagram down here, and we also have a picture of the eutectic structure in this system. That is a structure from exactly this point with the composition of 28.1 copper. So that's what we know, and what we want to figure out is what is the composition of this alloy. To do that, we need to know whether these primary precipitations, these dendrites and this eutectic, where in the phase diagram are we roughly? Well, are these dendrites silver dendrites that are we in this region, or is it copper dendrites, in the case, are we in that region? And to figure out that, we can look at the eutectic structure, because we see that the eutectic point is rather asymmetric, is rather close to the silver side of the system. It means that in the eutectic we will have much more silver than copper. We can actually use the lever rule on this eutectic line and calculate exactly what the fraction of silver and copper phase respectively we have in the eutectic. But we can see directly that we have much more silver. And when we look at the structure, what of these two phases, the light or the dark phase, is the smallest or largest? It's very clearly we see that the dark lines here are much thinner than the white lines. That means that the dark lines have to be the copper phase and the white phase is the silver phase. That's because we expect that the amount of silver should be much larger in this eutectic. So now we know that the dark phase is copper. And go back to this structure. Well, what do we see here? Well, that means that these dendrites, this primary precipitation, is the copper phase. This is copper dendrites forming here, these compositions. And that means also that we have to be in this part of the phase diagram. The next step is now to make an evaluation of the volume fractions of the two structural components. That is, how much primary precipitation, how much copper dendrites do we have, and how much eutectic do we have. That can be made in different ways. You can make a line analysis. You can also use image analysis system in the microscope. So if we assume that we do that, we will find that we have 60% dendrites and 40% eutectic structure. So that will be the background for the calculations we will continue with now. Well, we have 40% eutectic structure and 60% primary copper. That is, we write down that here, 40% eutectic and 60% primary precipitation. Primary copper, which was copper dendrites. And now we know that we are in this region of the diagram, and we just put in a line here and call that composition X% copper. That's what we want to calculate. And then we will make these lines. So we're going to have one line there and one line here, and we call this distance R and we call this distance S, as before. And then we're going to make some calculations here. So we know now that we have a fraction of eutectic, which is 40% of 0.4, which is a fraction. And that will be equal to the distance S divided by the whole distance r plus s. So that distance relative to that distance gives us the fraction eutectic. And now what is s? Well, s is 92.1 minus x, 92.1 here, minus x composition, and r plus s will be the whole distance, that is 92.1 minus 28.1. So it's 92.1 minus 28.1. This is a minus here. So that's what we can start with then. So we put in these two expressions in the equation up there, and that we get 92.1 minus x, and this is well, we calculate that for 64, so we divide that by 64, and that is 0.40. And if we solve this, we will get the solution, which is x will then be 66.5%, and that's the percent copper. So now we know that when we have a structure like the one in the figure with 40% eutectic and 60% primary copper, we are here, and now we calculate that to 66.5%, but it's actually here somewhere.